Now let's see the criteria for congruence of triangles. How do we prove a congruency of triangles? So there are in fact 4 criteria, but here you can see 5 because 2 angles and one side has 2 varieties. So these two actually belong to the same category, ASA and AAS. The order is only different. So there are 4 criteria. Here we can name them one by one. So this is number 1. Number 1 criteria, then number 2, then 3, and then 4. And this I told you, AAS is actually an extension of number 2. So there are 4 criterias. Now look here, the first criteria, that is SSS. So 3 sides of one triangle are equal to the corresponding sides of other. So here you can see single dash, double dash, triple dash. So 3 sides of one triangle are equal to the corresponding sides of other. So this, wait a minute, this triangle is corresponding to this because these two triangles have the corresponding sides equal. Now the second condition says 2 angles and the included side are equal. So 2 angles, which are the 2 angles? Let's see. This angle is equal to this angle, and this angle is equal to this angle. These 2 angles are equal, and the included side means the side included side means the side which is in between the angles. So this side equal to this side. So 2 angles of the 2 triangles are equal, and the side in between the 2 angles, or the joining 2 angles or 2 vertices, are equal. So that is why it is called included side. Okay, so 2 angles are in the included side. That is why here in ASA the S lies in the middle. ASA, so it is like in sandwich, S lies in the middle of 2 A's. That is better way of understanding it. Same way in SAS, you can see that in between 2 S, A lies. That means in between 2 sides, A will lie. So there are 2 sides which are equal. So here you can see that this side is equal to this side, and the other one, the other pair is this one, this side equal to this side. So 2 sides are equal. So S and S are equal, and then the included side, that side in between. So sorry, angle in between, included angle. So 2 sides are equal, and the included angle. So included angle, that means the angle in between is also equal. So here is the angle in between. This is the angle in between here, and angle in between here, in between the 2 sides. So that is why it is called SAS, right? If we number it, so number 1 is this. This is number 1 side, then number 2 side, and third, that is the included angle, right? So here number 1 side, number 2 side, and number 3 is the angle in between. So here side 1 equal to side 4, side 2 equal to side 5, and angle 3 equal to angle 6. That is how it is by SAS. The two triangles are congruent. Now two angles and an opposite side are equal. So it is by AAS. Now what is the difference between ASA? Look here. Look at these two now. These two conditions now. This one, this condition, and this condition. Just pay attention to these two conditions. Now here it is ASA and here it is AAS. In both you can see that there are two angles. There are two angles. One is this and the other is this, and one side. Here also two angles. One is this, the other is this, and the third one is side. But here the order is different. Here first the angle comes, then the side, and then the angle. And in the second one, angle, and then side. So that is why I said this is an extension of this, the other property. So here angle and then side. It's not the included side as it was in the previous case. Here it is included side, but here it is no included side. The side is outside. So now you can see here one is this angle in the first triangle, one is this first angle equal to this angle. The second one the second angle is this, which is equal to this angle. So now you can easily see the angle shown by yellow color are equal and the angle shown by light blue color are also equal. So two angles are equal, and then comes the side. So it is actually the first angle they are taking this. Let's start it. So here this is the first angle, number 8, and then number 9, and then comes the side. So angle, side. Now here if you see, so number 8 is equal to this number 11, then number 12, and the number 13. So in order we are going 8, 9, 10. A 8, 9, 10. That means 8 A S. Then here A and then S. That is how the two triangles are congruent by S. So I hope you understood the difference between ASA and AAS. Now the fourth condition is RHS. That means a right angle, the hypotenuse and another side equal. So here at the as the R says, R is for a right angle. R is for right angle. So here R denotes right angle, H denotes hypotenuse and S denotes a side. So that is how it is RHS. R means right angle should be there in both the triangles. So here you can see that there are two right angles. One is this, in the other triangle this is the right angle. Then H means hypotenuse should be equal. So hypotenuse should be equal in the two triangles. So let's see, this is the hypotenuse in this triangle, which is equal to hypotenuse in this triangle, are equal. And the third is the side. Now which side? It can be any one side which can be equal. So here it can be any one side other than the hypotenuse which can be equal, either this side or this side. So here they have shown this side equal to this side. It can be the other side also. Okay, so I am showing you it can be other side also, this side could have been equal to this side. So but you need only one side, another side. So that is why we have shown only one side other than hypotenuse to be equal. So it is by RHS they are congruent. Now let's try to understand congruency and criteria for congruence of triangles through an interesting video, a 3D video which will show you how a figure can be superimposed on another so as to show that the two triangles or two figures are congruent only if they overlap each other side by side or by shape. So this is how it is shown, and it is shown for congruence of triangles, and the four conditions are also shown in detail here. So watch the video carefully to understand it. Watch the video carefully to understand the concept
Congruence of triangles. In this module, you learn about the congruence
and the criteria
and the four criteria
for following
two triangles to be congruent to each other.
Proving of congruency.
Two triangles are congruent when you can superimpose one triangle on top of the other. Two triangles are congruent when the corresponding sides and angles are equal. Note that for triangles to be congruent, the corresponding parts should be congruent. The corresponding line segments should be equal in length, and the corresponding angles should have equal measurements. The side AB corresponds to PQ, BC corresponds to QR, and AC corresponds to PR. Similarly, angle A corresponds to angle P, angle B corresponds to angle Q, and angle C corresponds to angle R. In other words, the corresponding line segments are equal in length. Similarly, the corresponding angles have equal measure. You have to be careful when comparing corresponding parts of triangles. Here, triangle ABC is congruent to triangle PQR, but triangle ACB is not congruent to triangle PQR. Here are 6 possible conditions to determine the congruence of two triangles. Out of these 6 conditions, 3 are sufficient to determine that 2 triangles are congruent. These are called the criteria for 2 triangles to be congruent. We'll now examine these criteria for the congruence of triangles. SSS, or side-side-side criterion. If 3 sides of one triangle are equal to the corresponding 3 sides of the other triangle, then the triangles are congruent. Triangles may remain in any position in the plane. SAS, or side-angle-side criterion. If 2 sides and the included angle of one triangle are equal to the corresponding 2 sides and the corresponding angle of the other triangle, then the triangles are said to be congruent. ASA, or angle-side-angle criterion. If 2 angles and the included side of one triangle are equal to 2 corresponding angles and the included side of another triangle, then the triangles are congruent. RHS, or right angle hypotenuse side criterion. If in 2 right triangles, the hypotenuse on one side of one triangle are equal to the hypotenuse on the corresponding side of the other triangle, then the triangles are congruent. In this module you have learned, if 3 sides of one triangle are equal to the corresponding 3 sides of the other triangle, then the triangles are congruent by SSS criterion. If 2 sides and the included angle of one triangle are equal to the corresponding 2 sides and the corresponding angle of the other triangle, then the triangles are congruent by SAS criterion. If 2 angles and the included side of one triangle are equal to 2 corresponding angles and the included side of another triangle, then the triangles are congruent by ASA criterion. If in 2 right triangles the hypotenuse on one side of one triangle are equal to the hypotenuse on the corresponding side of the other triangle, then the triangles are congruent by the RHS criterion.